Okay, this is lesson 7.4 of Pythagorean theorem, and so we're going to be looking at right triangles today. A triangle that has 190-degree angle, which is usually marked with a box, so like this angle right here, this 90 degrees, is called a right triangle. So if you have a triangle that has a 90 degrees, you have a right triangle. The sides, or the outside, right? The sides are the straight edges on the outside of a right triangle, are called legs, and the hypotenuse. Okay, so the legs are the two that make up the 90 degrees. You see how these two meet at the 90. And your hypotenuse is the one directly across the 90 degrees. Okay, the two legs meet at the 90-degree angle. So in the orange, you see how the two outside legs meet at the 90 degrees. They create that box. Okay, those are going to be my legs. I'm going to mark them A and B. So let me do that right now. So I have A and B. And I use lowercase a and b, right, because it tells me to, and because the capital ones are already being in use. The longest side is called the hypotenuse. The hypotenuse is always the longest side in a right triangle, is across the 90-degree angle. So you see how I drew my arrow right here towards the hypotenuse across the 90 degrees? That means that this is my hypotenuse, which is C. Remember, we're talking about the outside. In a right triangle, if you're missing a side, you can use what's called the Pythagorean theorem, which is c squared equals a squared plus b squared. You might also see it as a squared plus b squared equals c squared. It's the same thing, where a and b are your legs and where c is your hypotenuse. I'm going to abbreviate it just because I don't have a ton of space. And so for the four problems below, we are going to use that equation, that theorem, to help us find the missing side. Remember, this only works in right triangles. You see how right triangle is capitalized? It means it only works in triangles that have a box. Remember, that box is 90 degrees. Okay, so we're going to find the missing sides, and then we're going to round to the thousandths place if we need to. Remember, thousandths is 3 decimal places. That's only if we need to, though. So let's start with letter A. Okay, I think it's helpful to write the equation. Okay, I'll write it up here. Just so that I have it. Let's remember that the box means 90 degrees. Okay, perfect. Directly across my box, right? Directly across my box, just like I have in my picture up here, is the hypotenuse. The hypotenuse is the letter C, lowercase c, right? Okay, the other two, the ones that connect, are the ones that make up my 90 degrees. These two are the ones that connect and make up the 90 degrees. This can be A and this can be B. So as I'm looking at my triangle, I see that I have numbers for A and for B. The only letter that I don't have a number for is my C technically, right? And there's an X in its place. So I'm going to solve for X. Okay, my 4 and my 3, those are legs. So this is a leg and this is a leg. C, since it's directly across my hypotenuse, or my 90 degrees, is my hypotenuse. So now I'm going to put my numbers and my letters or variables in their correct spot. So here I have a squared. Okay, a is a leg, a is 4. So I'm going to write 4 squared plus b squared. Okay, my b is represented by the letter 3, right? That's a leg, so this is 3 squared. Okay, that equals c squared. C is being represented by the letter x, so I'm going to write x squared. At this point, I have to square each of my numbers. Okay, so I'll square each one. So I have 4 squared. Okay, that gives me 16. So here, I'll lower this so I can write it. I have 3 squared. Okay, that's 9. And I still have the x squared. Okay, I'm going to combine the numbers that I have on the left side. So 16 plus 9. Okay, that gives me 25. 25 is equal to x squared. Okay, remember, I want just one x, and at the moment, I'm having x squared. So in order to get x by itself, I have to take the square root. So I just want one x, so I'm going to take the square root on this side. But whatever I do on one side, I have to do to the other side. The reason I do that is because the square root symbol cancels with the little 2. So on the right side, I'm only left with x. However, on the left, I have to take the square root of 25, so I'm going to do that. The square root of 25 gives me 5. Okay, and that's my answer, so x equals 5. Meaning that missing side, my hypotenuse, is going to be the number 5. Let's try letter B. Same process. We want to identify our legs and our hypotenuse so we can put our A, B, and C in the correct spot. Okay, so here's my 90-degree angle where I see the box. Across from it is my hypotenuse. And so my hypotenuse is represented by the letter C. This is my hypotenuse. Okay, the other two sides, the other two are my legs, the ones that make up the 90 degrees. I can call this A and I can call this B. This is a leg and this is a leg. Since A and B are both legs, it doesn't matter which one you mark as A and which one you mark as B because since they're both legs. Okay, my equation is right here, so I'm going to reference that when I'm writing out my stuff. Okay, my A is represented by the number 13. That's a leg, so I'm going to write 13 squared. Okay, plus B is the number 7, 7 squared, equals, and my C is being represented by the letter Y, the variable Y. So I'm going to write Y squared. Okay, and I'm going to square each one. So 13 squared is 169. Okay, plus 7 squared, 49, is Y squared. 169 plus 49 is 218. And you see how my y is squared? I just want one y. So in order to do that, I have to take the square root. So I'm going to take the square root of both sides. The reason I do that is because the square root symbol cancels with the little 2. So I'm left with y. Then we'll plug in the square root of 218. I get a decimal. Remember at the beginning it said round to the thousands place if necessary. That's 3 decimal places. Okay, so I'm going to look at my decimal and I'm going to count 1, 2, 3. I'm looking at the 4. The 4 is going to change if this number is 5 or higher. If not, it'll stay the same. Because this is an 8, that 4 will become a 5. So my answer is going to be 14.765. So y equals 14.765. Okay. All right, we have 2 more problems. So we'll look at letter C. Okay, my picture looks a little bit different, but that's okay. I'm going to approach it the same way. I think it's helpful to have the formula there on your paper so that you can see it. So I'm going to write it. But I can always reference this up here if needed or any of the ones that I already have. All right, my hypotenuse is across the 90 degrees. That's my C. The other two that make up the 90 degrees are my A and my B. Again, like I said, it doesn't matter which one is A and which one is B, so I'll put this one as A and this one as B. Okay, C is your hypotenuse. A and B are your legs. So I'm going to plug in my numbers or my variables into their correct spot into this equation. Okay, so for A is being represented by the number 8. So I'm going to put 8 squared. Okay, then I'm going to focus to B. B is being represented by the variable x. So I don't have a number here. I'm going to write x squared. So this one is a little bit different compared to the first two that we did. Okay, equals, and then I have my c squared. Okay, c is being represented by the number 14. So this is 14 squared. Okay, I'm going to plug that into my calculator and figure out what those numbers are. So 8 squared gives me 64. 14 squared is 196. Okay, I need the x by itself because eventually I want to take the square root. So what I'm going to do is I need to move the 64. The 64 is positive, and the opposite of that would be a negative. Whatever I do to one side, I have to do to the other side. These go away. I'm left with x squared equals, okay, 196 minus 64. I get 132. Alright, now that my x is isolated, I realize I have x squared. I need to take the square root to get just one x. So I'm going to take the square root here and here. I do that so that the square root symbol cancels with the 2. So I get x equals the square root of 132. Okay, I get a decimal, so I'm going to round to 3 decimal places. So I'm going to look at my decimal and I'm going to count 1, 2, 3. I end up at the 9. If the 1 is 0 through 4, the 9 will stay. If this is 5 or up, this will go up. But because this is a 1, it'll stay as 9. So my answer is going to be 11.489. And so my x here is going to be 11.489. All right, perfect. Let's look at the last one. We have a word problem. It says a ladder is placed 9 feet from the base of a house. The ladder reaches a height of 12 feet above the ground. Find the length of the ladder. And it says to draw a picture. So I'm going to draw a picture. All of these triangles are 90-degree triangles. So I'm going to place a little box right here representing the 90. Okay, let me look at the numbers and let me see where they go. So it says the ladder is placed 5 feet from the base of the house. When you think of base, I want you to think of the bottom. So look at your 3 sides of your triangle. You have 1 side, 2 sides, 3 sides. The side that's on the bottom is this one right here. So that 9 feet will go down here. Okay, it says the ladder reaches a height of 12 feet. When you're measuring height, height is straight up and down. So that means this side over here is going to be your 12 feet. Then it says find the length of the ladder. When you're using a ladder is usually at a diagonal, right? So like if I wanted to, I can kind of put that in my picture. So like if this is the ladder, that makes sense. Because here I can put my steps. And so this is what I'm trying to find. I'm trying to figure out how long this ladder is. So I'm going to put an X here. Okay, I can put X feet, right? Because I want to keep my units consistent. So I'm solving for what it looks like the hypotenuse. So if I go and I label everything, that's across the 90 degrees. That's my C. I'll use a different color. This is my C, which is my hypotenuse. Your 90 is made up by these 2 sides. Those are your legs. So, and it doesn't matter which one is A or B. So I can put A here, that's a leg, and this is a leg, and this is B. All right, so now I'm going to fill in my equation with the information I have in my picture. The equation is right here, and that's what I'm going to reference. All right, so A comes first. A is represented by the number 12. So I'm going to write 12 squared. B is represented by this side right here, which is 9. So 9 squared. Okay, and that equals x, right? That's the length of my ladder. That's my hypotenuse. So I'm going to write x squared. All right, in my calculator, I'm going to type in those values. So 12 squared is 144. 9 squared is 81. And then I have the x squared. So 144 plus 81 is 225. And because I have x squared, I just want 1x, so I have to take the square root. So I'm going to take the square root here and here. The symbol cancels with the 2, so I'm left with x. And then I have the square root of 225, which is 15. All right, so x is going to equal 15 feet. And I can write a sentence just so that I'm clear. The length of the ladder is going to be 15 feet. So let me write that. So the length of the ladder is 15 feet. All right, and that's the Pythagorean theorem.